Right now, as you watch this, there are entire galaxies, billions of them, that we will never see. Not because our telescopes aren't powerful enough, not because they're hidden behind something, but because the universe itself has drawn a line, and on the other side of that line, light cannot reach us. Not today, not in a million years, not ever. We call it the edge of the observable universe, and the reason it exists will make you question everything you think you know about space, time, and reality. Stay with me, because this one gets genuinely strange. I am your host. This is Photon Path. Let's follow the light. Here is the question that sounds simple but absolutely isn't. How far can we see? Most people's first instinct is, well, the universe is 13.8 billion years old. So light has had 13.8 billion years to travel. Therefore, the farthest we can see is 13.8 billion light years. Reasonable, logical, and completely wrong. Here is what that answer misses. The universe isn't sitting still, it has been expanding the entire time. The farther away an object is, the faster it appears to be moving away from us. Science and non-duality, so that ancient light didn't travel 13.8 billion light years through static space. It traveled through space that was itself stretching, like trying to swim upstream in a river that keeps getting wider. The result. According to NASA, the observable universe is approximately 93 billion light years in diameter, not 27.6 billion, 93. The very edge of the observable universe is now about 46 billion light years away, even though the universe is only 13.8 billion years old. Open learning that number sounds like a typo. It isn't, and understanding why is where things get interesting. Let's clear something up immediately, because this is the part that breaks most people's intuition. The edge of the observable universe is not a wall. It is not a cliff. It is not a place where space just stops. This boundary is not a boundary in space at all. It is a boundary in time. Science and non-duality here is what that means. Think of standing on a ship in the middle of the ocean. You can see out to the horizon, maybe 10 miles in every direction. But beyond that horizon, there is more ocean. You just can't see it, because the curvature of the Earth cuts off your view. Our cosmological horizon works the same way. Just like the ocean stretches beyond the sailor's horizon, space stretches beyond our observable universe. There is no reason why there can't be galaxies at these extremely large distances. They're just invisible to us, no matter how powerful our telescopes are. BBC Sky at Night magazine. The reason isn't the curve of the Earth this time. It is the age of the universe and the speed of light. Light travels fast, 186,000 miles per second. But it is not infinitely fast, and the universe is only 13.8 billion years old. That means there is a hard limit on how far any signal, any information, any photon can have traveled since the beginning of everything. Beyond that limit, we're blind, not because there is nothing there, but because the light from those regions simply hasn't had enough time to reach us yet. Now here is where it gets stranger still. Some of those galaxies, the ones right at the edge of what we can see, are moving away from us faster than light. Wait, isn't nothing supposed to move faster than light? Einstein said nothing can travel through space faster than light. And that is true, but here is the loophole. Beyond roughly 16 billion light years, galaxies recede faster than light due to the expansion of space. That is allowed in relativity because it is space itself expanding, not the galaxies moving through space faster than light. Superfacts imagine drawing two dots on a deflated balloon. Now inflate it, the dots move apart, but neither dot moved. The rubber between them stretched. That is what is happening to the universe. The galaxies aren't speeding away from us. The space between us and them is growing. And when enough space accumulates between us and a distant galaxy, the space expands faster than light can cross it. Which means eventually, most of them will cross a boundary called the cosmic event horizon. Once they do, their light will never be able to reach us, not even given infinite time. Superfacts, some of those galaxies are gone forever, already beyond the point of no return. We can still see their ancient light right now, but that light left them billions of years ago. The galaxy itself, unreachable. Permanently, and here is the darkest part of this story, it is getting worse. In 1998, astronomers discovered that not only is the universe expanding, the speed of that expansion is increasing. Space.com, something is pushing space apart, faster and faster. We call it dark energy. And as of this year, after a brief scientific controversy in late 2025 where some researchers suggested dark energy might be weakening, the evidence for cosmic acceleration has been confirmed to remain remarkably consistent. Science daily dark energy is real, the expansion is accelerating, and the horizon is slowly swallowing more and more of the universe permanently. Now, here is a question almost nobody asks. What do we actually see when we look at the very edge of the observable universe? Not galaxies, not black holes, not empty space. We see a faint, uniform glow, a wall of microwave radiation that fills the entire sky in every direction. Scientists call it the cosmic microwave background. The CMB, about 380,000 years after the Big Bang, the universe was finally cool enough for atoms to form. Before that, it was an opaque plasma fog. Photons of light were constantly bouncing off free electrons. Unable to travel in straight lines, unable to escape, like light trying to pass through a dense cloud. Then, in a cosmic instant, the fog cleared. Atoms formed, light broke free. And those photons have been traveling in straight lines ever since, for 13.8 billion years until they hit our telescopes. When we map the CMB, we are looking back in time to just 380,000 years after the Big Bang, just after the universe became transparent to light. That faint glow, it is literally the oldest light in existence. The very first photons the universe ever released. And here is the haunting part. That surface of last scattering acts as a fog to our electromagnetic view of the universe at earlier times. We cannot see past it with any telescope, no matter how advanced. Beyond it, the universe was opaque. Before 380,000 years after the Big Bang, darkness, a wall we cannot see through. So the edge of what we can observe isn't just a distance limit, it is a time limit. We are literally unable to see the first 380,000 years of the universe's existence. That chapter is sealed off by physics itself. Now here is the part I promised would break your brain. Everything we've talked about, the 93 billion light-year sphere, the CMB wall, the accelerating expansion. All of that is our observable universe. But here is what science can't tell you: how big is the actual universe? Current theories suggest the cosmos may be vastly larger than what we can see, possibly infinite. If inflation theory is correct, the universe could extend far beyond our horizon, perhaps into realms forever inaccessible to observation. Think about that. There may be regions of the universe full of galaxies, stars, planets, potentially even life, that are so far away that their light will never reach us. Not in a billion years, not in a trillion. Their existence is physically sealed off from us by the nature of space-time itself. We are living inside a cosmic bubble, one sphere of observable reality, surrounded by an unobservable expanse that may be infinite. And here is the final gut punch. Every location in the universe has its own observable universe, which may or may not overlap with the one centered on Earth. Wikipedia somewhere, potentially trillions of light years from here, there might be an alien civilization looking out at their observable universe, their cosmic bubble, and ours might not overlap at all. We are not just separated by distance, we are separated by causality itself. We exist in fundamentally different slices of reality. Slices that can never interact, never communicate, never even know the other exists. The universe isn't just big, it may contain entire regions of existence that are, by the laws of physics, permanently beyond the reach of any being anywhere, forever. So why can't we see the edge of the universe? Because the edge isn't a place, It is a horizon, like a ship's horizon, defined not by what is there, but by the limits of light, time, and an expanding universe that is racing away from us faster than we can ever chase it. The observable universe is 93 billion light-years across. It contains an estimated 2 trillion galaxies. It holds everything we will ever be able to observe, measure, or know. And it may be just a tiny, thin slice of something incomprehensibly larger. That is cosmology. That is physics. That is the universe telling you, very gently, that your imagination isn't big enough, and neither is mine. If this video made you feel small in the best possible way, hit like. It tells YouTube this content is worth sharing, and it genuinely helps this channel reach more people. Next week on Photon Path, Dark Matter. 27% of the universe is made of something we cannot see, cannot detect directly, and cannot explain. And it may be the most important thing in existence. Subscribe so you don't miss it. I'll see you then. Follow the light.